Okay, so we got an electron, right? Okay, so our charge is really negative 1.60 e minus 19, right? And our mass for the mass of an electron is 9.11 e 31st, right? Notice that that's milliteslas. I might throw you off. And this is millimeters, right? It's like, ooh. Okay. Okay. Notice, okay, so now notice that this question is the electron going straight up the page. So let's draw a picture of our electron going straight up the page in a magnetic field that's into the page. So the magnetic field is like, let's figure out which way this guy's going to circle. Okay, so index finger, and this is the key thing, right? Is you want to use whatever direction they give you in the second problem. Draw a picture of it there. It'll save you some work. Okay, so index finger is up the page. My middle finger is into that page. My thumb is now pointing to the left, but it's an electron, so it's negative left. So the magnetic force will be to the right, which means this guy is going to go clockwise. So clockwise is the correct direction. Okay. Now to figure out what the velocity is, we're going to set the QVB equal to mv squared over r. Okay. And then let's solve this for v. One of these v's cancels, right? Okay. So I think it's QRB over m is v. Okay. We can do this. So Q is 1.6 e minus 19. And it doesn't make sense right now to put a minus in there because I'll get a negative velocity. What does it mean? I mean, it probably does mean something in some smarter thing, but I'm not very smart. All right. So, okay, so this guy is 2.65 e minus 3. And then milliteslas, right? I'm not even going to try to move the thing. I'm just going to go 0.0312 e minus 3. Okay, and then, I mean, you could move the decimal place 3 places, but I'm also a spaz. And then what's the mass? The mass is 9.11 times 10 to the minus 31st. So let's type that in. Let's see. I got this guy, 9.11. And then I got to go 2.65. And then let's see, this guy is 10 to the minus third. Don't forget the milliteslas. I did forget the milliteslas. That's why I'm saying that. And I get that this is, that our velocity is 14521.18, something or other, right? So 1, 2, 3, 4. So correctly, we would write 1.45 times 10 to the 4th meters per second, and it's going to go clockwise. Okay. Now, here's the question, right? Okay. What electric field in what direction will make the electron go straight up the page, right? So what we need is an electric force to the left. Okay. Now, to get an electric force to the left on an electron, we have to have an electric field that's to the right. Let's think about this. Why is this? Why? Okay. To make a field to the left, you have an electric field that's to the right, and here's why. Let's generate this electric field. This is an electric field to the right. Okay. Notice that this field is this way. Because remember, it's always the direction of electric field is always what would positive charge do, right? Okay, so in this situation, a positive charge would feel a force to the right, but a negative charge would definitely feel a force that way. Okay, so that's why the electric field has to be to the right. Okay, and then as far as what electric field, we're just going to use QVB is EQ. Right, the Q's cancel. And so E is going to just be VB. And what's our velocity? Oh, we don't know what it is. Oh, there it is. It's 14521.18. And our magnetic field is 0.0312. Don't forget that it's to the minus third. It's milliteslas. Milli. Don't forget that. Okay, because I forgot that. Okay, so I'm going to take this number and go times 0.0312. And I get that it's 0.45306. So I think this should be a 3. Okay, and that is newtons per coulomb. And the reason why that number's off probably is that I use a different value. I used a 1.602 when I did this, which, you know, doesn't make me wrong. And then that would be to the right. Okay.